Welcome back, everyone. Today in stats, we're going to be looking at the confidence interval for the mean of differences. And what that means is we're going to have an experiment that has a before and an after. And then we're going to take a difference of the before and the after, and then take averages of those differences. And you'll see what I mean as we do this. Now, you should know that all of this data does come from experiments that were run. We did them online one night and, compiled the data. It wasn't easy, but these are the statistics that came out of me doing this experiment a bunch of different times. So let's see what we have. Does memory training help? You'll be given a list of words, and then you're going to be given 3 minutes to memorize as many as those possible just by rereading the words. You will record as many words as you can remember, and then you will be given another list of words to memorize for 3 minutes using a memorization strategy. So basically, there are two strategies. One is just rereading over and over again. And the second one, since you're not going to do the experiment at home, that's going to be, or that was, making a story out of the words and seeing how many you could memorize. So how many words did you get correct? Well, for me, I got 9 words correct. Oops. Using the second strategy, I got 12 words correct. So there was a slight improvement for me. So does that mean automatically that there was an improvement? I mean, if you said yes to that, that means that you didn't take statistics because maybe that was by random. Is there enough evidence to suggest that I couldn't have had a 3-word increase just by random? And no, there isn't that evidence. So here is the results, or here are the results from the experiment that we did online. You'll notice that most people did improve. We had a total of 24 people, including myself, do this experiment. And down below, you will also see the dot plot of the experiment. So take a minute here. No, actually, let's do this one. What does this dot plot suggest about the memory training? Well, it kind of suggests, since most people have an improvement, it suggests that there was an improvement in the number of words memorized using the second method, which was making a story. Okay? Next, find the mean and the standard deviation and then interpret them. I'm going to give you a second to do that on your calculator. I will leave the data up here so you can enter the differences into your calculator and use one-var stats to figure out the mean and the standard deviation. So pause here for you. And here we go. The mean was 2.25 and the standard deviation was 2.13. So what is the interpretation of that mean? Well, it means that on average, people remember 2.25 more words using strategy B. Scrolling down, construct a 95% confidence interval for the true mean difference in words remembered by students using the rereading and story. So this is a 4-part plan again. Remember, state, plan, do, conclude. Firstly, we're going to state by looking at the parameter and statistic and the confidence level. So what was that parameter? Well, parameter is a mu, and the mu is the true mean difference in words remembered. Well, if the parameter mu is a true mean words remembered, what is our statistic? The statistic then is x bar, and it is the mean number of words remembered in our sample of 24. Remember, that number was actually 2.25. You should have a number for x bar. You shouldn't have a number for mu. I mean, if you knew the value of mu, why are you doing stats to begin with? Confidence level. What is a confidence level? Well, we're given that the confidence level is a 95% confidence level. That's going to help us find our value of t star, and that's also going to, with the degree of freedom. So that takes care of all the stat part. Next, we have to plan. So the next part of the plan is the name of the procedure. So we have means. We have one sample, or do we have two samples, or do we have a weird mishmash of the two? And is this going to be a t interval or a z interval? Well, as it turns out, it's going to be a one sample t interval for a mean of a difference. So remember, we took the average of all those little subtractions. So we're doing a t interval for those subtractions. And really at this point, the other two lists for method A and method B don't really matter. So from here on out, this looks just like one sample because, we don't need those other numbers. We just want to know about the improvement. Okay, check conditions. What is that first condition that you need to check? Well, yeah, you have to check if this is a random sample. And to be honest with you, this wasn't a random sample. Since I put this on the internet, this was actually a convenience sample. We just took the first 24 people who happened to be there. But we're going to assume right now, since we have no other way of doing this, that this was a random sample of high school students, or at least random enough for us to work. The remaining two conditions, what were those? Okay, so we had to check the 10% condition. Were there more, or is our sample smaller than 10% of the number of high school students? Well, if our sample size was 24, 10 times our sample size is 240. So that basically means there has to be more than 240 high school students, which sounds pretty reasonable. Next, for normality, we needed to make sure that, number one, the population was normal or approximately normal. No, that didn't work. We don't know if the population is normal or approximately normal. So if that fails, we go to number 2, which is, do we have a large sample? And by large, we mean more than 30. And no, again, we only have 24 in our sample. So that leads us to number 3. And failing 1 and 2, is the histogram or the dot plot, is it reasonably symmetric with no outliers? And if we take a look back at the dot plot, yeah, that's reasonably symmetric. I don't see any outliers on there. I have no reason to believe any of those are outliers. So yeah, the dot plot is reasonably symmetric with no outliers. Now we're at the do section. So we need the general formula, the specific formula, we need to show the work, and then we need to show the answer. So first of all, how about that general formula? The general formula for any confidence interval is, it's a point estimate plus or minus the margin of error. Okay, now that we have that, we just got to think about what is a point estimate and what is a margin of error. Remember, this is where t comes in. So, since it is t, we probably should remember we have a degree of freedom. So the degree of freedom is 24 minus 1, which is 23. Remember that sample size minus 1. How about that specific formula? What is a specific formula for the confidence interval for t? Well, that is x bar plus or minus t star s over square root of n. Now that doesn't look like a t star right there, but that is a t star, and we'll get that fixed right now. Much better. Work, all you need to do is substitute those numbers in there and then do all the multiplication. So here's our work. We're just going to substitute the numbers. There we go. Our t star was 2.069, and that comes right out of your calculator, an inverse t. Remember, we're looking at a normal curve where the central area is 0.95, so each of those tail areas are 0.025. So in order to get the t star, you're going to need to calculate an inverse t of 0.025 with 23 degrees of freedom. Now remember, this calculator notation, this is going to give you a negative number. You just make that number positive. Back to the work. Once we multiply all of the margin of error stuff together, we get 2.25 plus and minus 0.9. So that is our margin of error, 0.9. Last, we're going to conclude. Remember to interpret the interval in context of the problem. So first of all, let's try to remember what that Mad Lib is for the interpretation of a confidence interval. All right, interpret, here's our Mad Lib. We are, and then I think we're just going to fill this in, right? 95% confident that the interval from, let's do some subtraction real quick, 2.25 minus 0.9, that's 1.35. That 1.35 to 3.15. And then I think it might be nice if we had some units here. Words captures the true value of the mean increase in words remembered using strategy B. Okay, and that's our, that's, yeah, remembered. That is our interpretation. We didn't do anything new here. We just used our set phrase. Number 6, do we have evidence that the average number of words remembered using, that there is a difference? Yes, we do. We know that because our entire interval is positive, we have evidence that strategy B leads to more words remembered. Okay, and that's because we had a positive difference. Remember that if you have a negative difference, that means that strategy A, would have meant more words remembered. If you have some negative and then some positive, well, that means that you can't tell which strategy is greater, and it's possible that the two strategies lead to the same number of words remembered. Let's hit the important ideas here. Important ideas. When we're describing the distribution, if we have measurements that are less than 0, that means that the second method or second technique is larger. If we have differences that are greater than 0, that means the first technique is larger. So that is X bar difference and S difference are the two things that you need to calculate in order to get this done. Remember, the mu is not a mu of any one particular strategy. It is the mu of the difference. Now, everything about this is just like a one sample t-interval because it is a one sample t-interval. It's a one sample t-interval for mu difference. There is a general formula, x bar difference plus or minus t star, s difference over root n. And that leads us to check your understanding. Researchers designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as their subjects. Each subject was barred from coffee, colas, and other substances with caffeine for the duration of the experiment. During one 2-day period, subjects took capsules containing normal caffeine intake. During another 2-day period, they took a placebo capsule. The order in which the subjects took the caffeine and placebo was randomized, and so at the end of each 2-day period, a test for depression was given to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression at the alpha equals 0.05 significance level. Okay, the table below contains data on the subject scores. On the depression test, higher scores show more symptoms of depression. So the very first part here is to make a dot plot of the difference in depression scores, caffeine minus placebo for each subject. What does the graph reveal about the differences? Okay, so take a minute here, compute those differences, and then make a dot plot. We'll go ahead and do the same over here. So you can see from the dot plot that almost all of those scores are negative. We only had one that wasn't negative, I think. And since almost all the measures are negative, the placebo scores were higher, meaning more depression symptoms with the placebo. Number 2, find the mean and standard deviation for the difference in depression scores. Interpret the mean difference in context. So grab your calculator and let's get those scores in there. Find the mean and the standard deviation. Remember to use S. Don't use sigma. So you should have gotten an x-bar difference of 7.365 with a standard deviation of the difference at 6.918. What does that interpretation mean? Well, it means that on average, the placebo score was 7.365 points greater than the caffeine score. So we're going to construct and interpret a 90% interval for the true mean difference next. So that says to me we need to do a 4-step plan. Let's go to it. 4 steps. First of all, let's do their state. Okay, state, mu is the true mean difference depression scores. X bar is the mean difference in a sample of 11, which we got a number for. That is 7.365. Plan-wise, the name of this test or interval is a one sample t-interval for mu difference. Conditions, the problem said random, so we're quoting that there. There are greater than 110 caffeine dependents, just look at your high school faculty. And then the dot plot, which we drew above, was roughly symmetric with no skew. Time to do. Okay, we have the general formula is the point estimate plus or minus the margin of error, which for mu diff means mu diff, x bar diff, sorry. For mu diff, this means x bar diff plus or minus t star S diff over root n. So the numbers that we have in there for x bar diff is 7.365. Our t star for a 90% confidence interval and 10 degrees of freedom is 1.812. S diff we saw already was 6.918 over the square root of 11. And we get 7.365 plus or minus 3.780. Lastly, we need to conclude. We are 90% confident that the interval from 3.585 to 11.145 captures the true value of the mean difference in depression scores. And now that I'm looking at that, I'm remembering that X bar difference was supposed to be negative, right? So let's change that to negative, and let's see where the calculations change. Well, really not a whole lot changes. Our interval does kind of right itself. So the interval is from negative 11.145 to negative 3.585. So that is the end of our day 1. So hopefully you had a decent time of it, and we will see you for day 2.